Hi everybody. In this section we're looking at permutations and repetition. In the last section we just looked at permutations, how many different ways we can arrange different objects in so many spaces. This time we're looking at arranging objects, however we'll have a repetition of one of those objects. So we want to figure out how many permutations we could do, but we don't want to double count if one of the objects is exactly the same. So in example A, we want to arrange the word tooth in as many ways as we can. However, the T and the O repeat. So in the formula, we're going to use the same permutation formula. Then we're going to divide by the number of identical objects in the group. So in this problem, we have n equals 5 and r equals 5 because we have 5 objects and 5 slots. And x sub 1 we have 2 because there's 2 O's, and x sub 2 would also be 2 because there's 2 T's. So in the formula we're going to use the permutation formula NPR divided by x1 factorial x2 factorial. So 5p5 would be 5 factorial divided by 5 minus 5 factorial divided by 2 factorial times 2 factorial. So again, this numerator is just the permutation formula that we used in the last section. So 5 factorial divided by 5 minus 5 factorial is 5 factorial over 0 factorial. Remember, 0 factorial is just 1. So this is the same as saying 5 times 4 times 3 times 2 times 1 divided by 2 times 1 times 2 times 1. So now we can simplify and multiply. What we have left here is 5 times 3 times 2, which is going to give us 60. So if we had a 5-letter word that didn't have any identical objects in it, we would have much more permutations than if we have a repetition. So in example B, we have the word apple, and we want to see how many ways we can arrange this. So we have 5 objects again, and we have 5 spaces. So we have n equals 5 and r equals 5. And we repeat 2 p's, so that means x sub 1 would be 2. So I get 5p5 divided by 2 factorial. It's going to be 5 factorial over 2 factorial. So it's going to be 5 times 4 times 3 times 2 times 1 divided by 2 times 1. So it's going to be 5 times 4 times 3. So we've got 60 different permutations, which is half if we didn't have that one repeating p. Okay, in example 6 we have a 6-digit numerals, and we have 7 to choose from. So we have r in this case is going to be 6, and 7 are the number of objects n. And the digits we're using is 33, 444, and 56. So you can see we repeat the 3 twice and the 4 3 times. So n is 7, r is 6, x sub 1 is 2, and x sub 2 is 3. So we're just going to put it into the formula. We get 7p6 over 2 factorial, 3 factorial. So this is going to be 7 factorial divided by, this is going to be n minus r factorial. So that's 7 minus 6, because we have 7 objects and only 6 spaces. And we're going to divide this whole thing by 2 factorial, 3 factorial. So 7 factorial divided by 1 factorial, all divided by 2 factorial, 3 factorial. So 1 factorial is just 1. So basically we get 7 factorial over 2 factorial, 3 factorial. So let's expand this. 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 and then 3 times 2 times 1. And then just see what simplifies here in the numerator and the denominator. So multiply these together here. 42 times 10, this is 420. So there are 420 permutations for this problem with these two repetitions. Okay, last problem here. See if you can try this on your own before you look at the solution. We have 4 chocolate chip, 2 oatmeal, and 2 double chocolate chip cookies in a box. How many different orders is it possible to eat all of these cookies? So there's lots of repetition here, and we need to account for that. So we have 8 objects, we have 8 spaces for them, and we have 3 different objects that are being repeated. So I get 8p8 over 4 factorial, 2 factorial, 2 factorial. So 8p8 is the permutation is just going to be 8 factorial divided by 8 minus 8 factorial, and then all over 4 factorial, 2 factorial, 2 factorial. So you can see how this simplifies. I'll expand all the factorials here. There is the way to use the calculator for the factorials, but if you can do it by hand, the better. So I get 2 times 7 times 6 times 5. 840 different permutations. And that's it. So I hope this section makes sense. Go ahead and try the practice set.